Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video we will show you how to develop an assembly language program to find the square of a given number using lookup table method. So let us start the video, but before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel, click on bell icon and share this video to your friends. Let us start. Guys, if you want to find a square of a given number, one important thing you should know: the square can be found out easily by multiplying by the same number. But here we're not using that method. We're going to use lookup table method. So what do you mean by lookup table method? So you can see this blue color table. So blue color table, whatever you're seeing, this is called memory location allocated. And in these memory locations, we're going to store the square of each number. Example, here you can see input number I have taken from 0 to 10. These are all my input numbers, let us assume, and the square of respective numbers we have stored in the memory location. So this is called as lookup table method. So we are going to define an array. In that array, we are going to define the square of a given number. Okay, now if you observe here, this is my first memory location, and here I kept it. We're going to define the square of a number 0. So 0 square is 0, then 1 square is 1, 2 square is 4, then 3 square is 9, and it goes on like that. Finally 10 square is 100. So you should also know one more important thing, we have to save this data in a hexadecimal format for easy understanding. Square of a number in hexadecimal, so I'm going to save in a hexadecimal format. First thing. Second important thing is, if you observe here, each memory location address, we're going to save these squares in a consecutive memory locations. If you observe here, the difference of each memory location, so this is 0, this is 4, this is 8, and it goes on like that. Every number is going to be stored in a memory location with a 4 bytes of difference, 4 memory location difference. So 0, 4, 8, C, like that we're going to store it in the memory location. So this concept is called as lookup table method, or a table method we will call. Now how to find a given square of a given number? Now we will tell you how to do that. In order to find a square of a given number, so now we have to follow 2 to 3 simple steps we have to follow. The first thing is we have to define the table, lookup table. It's very straightforward. Just you define an array with this value. That's it. Now you can see here the first point what I have kept it here. Each number square is stored in the array in the form of array. That is what you are seeing here. Each memory location is of 4 byte. If you observe here, each memory location of each square which we have stored is difference of 4 bytes. Now to find the square of a given number, multiply the given number by 4 to get its square address. So this is very important. Point number 4 and point number 5, these two are very important. These 2 points we're going to implement in the program. If you want to get a square of a given number, multiply given number by 4. So why we have to multiply by 4? If you observe here, each number or each memory location is having the difference of 4 bytes. Each memory location is difference of 4 bytes. That is why we have to multiply it. For example, if you want to get the square of 1 means, so 1 into 4 we have to do to get the address of your square. Similar to that, if you want to find a square of 2, you multiply by 2. Multiply 2 by 4, that is 8. Similar to that, if you want to get a square of 3, multiply by 4. 3 into 4 is 12. 12 is nothing but C. Similar to that, 4 into 4 is 16. 16 is nothing but 10. Like that. So if you want to get the address, so now we're not directly going and getting the square, but instead of that, first we're going to calculate the address, then we're going to take the data from that memory. So that's what here I kept it. So we have to multiply given number by 4 to get the square address. So that means this address first we have to calculate, and later we have to fetch the data. Okay, so this is one way you can multiply. And the second important thing, this multiplication can be achieved by performing left shift operation by 2 positions. So either you can if you have a multiplication instruction, you can directly use mul given number by 4. that is also you can do it. Or if you do not have the multiplication instruction, or if the multiplication instruction is not supported, then you can use this method as well. Shift the given number by 2 position. That will also produce the same result. So either you can multiply directly by 4, or you can shift by left shift by 2 positions. The blue color which I have highlighted, this is the suitable concept or a suitable logic we have to apply in the program to get the address. So once if you get the address, directly you can use you can fetch the data which is present in the memory. Okay, so guys, you can see here this is my lookup table. I have already defined my lookup table. So this point, whatever you are seeing here, this is my lookup table. This complete is my lookup table. I have defined a lookup table for 10 numbers, nothing but 10 square numbers. The same thing whatever I have shown you in the slide, the same thing here also I kept it. 0, 1, 4, 9, 16, 25, then 36, then the 49. So these are all hexadecimal value. Okay, so this I have already defined the lookup table. Now what I'm going to use, I have to use a memory pointer as usual in a regular method. How we're going to use, we should have one memory pointer. That memory pointer I'm going to consider, that is R0. Okay, so R0 LDR R0 is equal to table. Table is nothing but whatever I had defined here. Okay, so for load, so this is nothing but I initiate the memory pointer. So memory pointer to the table. So first step is done. I have defined the memory pointer to the table. Now after this, what I have to do, second point, you see input number to find the square. I need to define one input number to find the square. You can use any register. I'm going to use something like this. Move R1 comma hash 5. Okay, I'm going to use R1 register as a input register where I want to store my input number. Then after that you can use I need to multiply by 4 now, so I have already shown you here. So this, either you can use direct multiplication by 4, or you can use even left shift operation by 2 position. Both are correct. You can use anyone. I'll be using a second one here, left shift by 2 position. Left shift by 2 position to get the address, to get the offset address. To get the offset address of the square. Okay, so how to do? Just very simple. What we have to do, so we have to perform move R1 comma R1 comma LSL by 2. So this instruction, whatever you are seeing on the screen, it is going to perform left shift operation of R1 by 2 position, and then later result is stored back to register R1. That is the meaning here. So if you split it up, this, it is having a two important thing. R1 contents will be left shift by 2 position and store the result back to R1 register. Okay, to why we're using, to get the offset address of the square. Okay, that is the thing. Next, after that I need to add to my memory pointer. So I have a memory pointer here. So this memory pointer address plus offset address, both I have to add it. So to do that, a simple thing, add R0 comma R1. Very simple. So just you add your R0 comma R1. Okay, so when you add your offset address, nothing but your R1 and R0, both it is going to produce a new address which will point to the address where your square is located. And after that you just store the result in register R2. So nothing but square. So this is going to store the square in register R2, and finally you can just stop the program. Let us compile this. So 0 error. So guys, this is your debug window. I'll just enter into a debug session. Yeah, the first important thing is try to understand what is going to happen in the line number 8. So currently whatever you're seeing here, the line number 8, your program counter is pointing to the line number 8. nothing but ldr r0 comma table. So now table I have defined somewhere that I will show you now. So first you should get the starting address of your table. So how to get? So when you execute this instruction, the R0 will be loaded with some value. So initially R0 is loaded with some junk value. So once if you execute this instruction, R0 will get updated with a memory pointer address, nothing but where your square of numbers are stored. Okay, so when I execute this, it will open it. Now I'll execute this. Now you can see the R0 got updated with some F0. F0 is the address of your table. So table whatever you're seeing, the same address is updated here in R0. So R0 is having F0. Now I will type it here, F0. Now you can see. So this is the, so now I got to know my initial memory pointer address, that is located in F0. So next step, I'm going to give the input, the number to which I want to find out a square. So you can see here line number 10 is a number. I want to find out a square. I'll just execute this instruction. Now R1 got uploaded with 5. Now that is done. Now next step is I want to find out the offset address of your square. In order to do that, I'm going to use this instruction, move R1 comma R1 LSL by 2, nothing but left shift by 2 position, store the result back to R1. So when I do that, so I'm getting some value that is 1/4. So this is an offset address, and from this offset address I need to add it to my memory pointer address. Now add to the base address. Here I got offset address, and that offset address I'm going to add to the base address. Okay, just execute this. Now you can see your R0 memory pointer address also changed, right? So now it is 104 it is showing. So when I say 104, though this is the 104 address, see here. So 104 is the address, and the value which is stored in this 104 is 19. The input value is 5. So what is the 5 square here? So what is this 5 square? 5 square is 25, right? So 104, here it is. Okay, so 5 square, you know that already. 5 square is 25 in decimal. The same thing if you write in hexadecimal, it is going to be 0x19. Okay, the same thing whatever you're seeing. So I have calculated offset address, added with the base address, and when I point to that address, I will get the square of a given number. Okay, that's 19. Now after that, what I'm doing, I'm just loading the square of a given number into the register R2. I'll just execute here. You can see here. So this is my square of a given number, finally, which is going to store in register R2. Okay, the same thing, right side whatever you're seeing, the same address I kept it, but this is showing in a decimal. Okay, so don't get confused. This is a decimal. This memory location I kept it in a decimal format. You can change it. The memory location addresses values, you can change it to decimal and hexadecimal. Both are same. Just you need to change the format. That's it. So this is your hexadecimal. This is your decimal. Okay, so I hope this video is an informative video. If you feel this video is informative video, please click on like button and subscribe to my YouTube channel. Click on bell icon and share this videos to your friends and colleagues.